All right, let's jump right into this explainer. Today, we're taking a look at the absolute bedrock of building comfort, and that is the heating and cooling load calculation. Now I know, it sounds kind of like a dry, highly technical engineering term, but I promise you, it is literally the invisible force dictating whether you are cozy, productive, or utterly miserable inside your own home. Every single year, millions of dollars in energy bills are completely wasted simply because of a massive misconception about this one fundamental concept.
You know the feeling, right? Why are some rooms impossible to keep warm, while others just feel incredibly stuffy? We've all been there, shivering in a freezing office where you're wearing a heavy sweater in July, or sitting in a drafty home where you're sweating in December. The frustrated energy we feel usually boils down to one incredibly common problem in the construction and home improvement world: relying on absolute guesswork instead of rigorous science.
So how do we solve this agonizing issue? Well, to get the definitive answer to indoor climate control, we have to look at a precise heating and cooling load calculation. The secret to perfect comfort isn't buying the absolute most expensive thermostat on the market or, installing the biggest fan you can find. It all comes back to this specific calculation. There's no magic to it at all, really, just pure math and building science. But what exactly does that phrase mean in practical terms? Let's break it apart. Section 1. Decoding heating and cooling, the battle against the elements. You see, your home is basically fighting a constant two-front war. By the laws of physics, heat always wants to move from a warm place to a cold place. That's the invisible enemy your building is constantly fighting. Heating is all about replacing the heat that's continually being lost to the cold winter outside. Think of your house like a leaky bucket, and the heat is the water escaping through the cracks. No matter what you do, heat is migrating outwards. Cooling, on the other hand, is the exact opposite. It's about extracting the excess heat gained during the scorching summer. Your building is essentially a ship, and it's constantly taking on heat radiating from the sun while simultaneously trying not to leak its own conditioned air out. You're always either bailing water out or trying to keep it in.
Which brings us to Section 2, Understanding System Load, Measuring the Battle.
Okay, so what is thermal load? It's actually the exact precise measurement of the heating or cooling energy required to maintain a comfortable indoor temperature against those outside elements. Instead of being intimidated by that kind of industrial-sounding word load, just think of it as a scientific measurement of that exact battle against heat loss and heat gain we were just talking about. It's really crucial to realize that load isn't the equipment itself. It isn't your air conditioner or your furnace. Rather, it's the specific burden placed on that equipment by your house. It's the numerical value of your building's struggle against the weather outside. Moving on to Section 3, the calculation process, going from guesswork to science. A true calculation is totally comprehensive. It demands that we evaluate highly specific physical variables instead of just using some crude rule of thumb. We aren't just looking at the building's total square footage. We're evaluating the exact R value of the insulation hidden inside the walls, which dictates how fast that heat is escaping. We're assessing the number, the size, and the efficiency rating of every single window you have. We're even pulling in incredibly specific local climate data. Actually, here's a crazy fact for you. A house facing west with huge, beautiful windows will have a drastically different cooling load than the exact same house facing north. The solar radiation hitting that glass completely changes the math. You simply cannot just look at the floor space and make a guess.
So how does this actually work in practice? Well, step 1, professionals carefully measure your building's shell. That's the exact dimensions of the walls, the roof, and the floors. Step 2, they input highly specific historical weather data for your exact zip code, so they really understand the extremes of your local summers and winters. And finally, step 3, they determine the exact capacity your equipment needs to overcome those extremes. It's a precise mathematical formula tailored entirely to your unique living space. It literally leaves zero room for assumptions.
And that leads perfectly into Section 4, Why Accuracy Matters, the bottom line. We've essentially got a Goldilocks situation here when it comes to the consequences of this math. You might think, hey, bigger's always better, right? Just get a massive air conditioner and cool the house down in seconds. But actually, no, scratch that. An oversized unit is a total disaster. It short cycles, it blasts freezing air, and then turns off way too quickly. And because it shuts off so fast, it completely fails to remove the humidity from the air, leaving you feeling really cold and clammy. Plus, starting and stopping that massive motor wastes incredible amounts of energy. Conversely, an undersized system is just as bad. It constantly struggles, running nonstop but never actually getting your house to a comfortable temperature. That causes excessive wear and tear while driving your electric bill right through the roof. But
But a calculated system, that one is just right. It operates efficiently, running long enough to properly dehumidify, saving you money and keeping the comfort levels absolutely perfect. Think of an HVAC system like a pair of shoes. If they're too big, they're clumsy and inefficient. Too small, they're painful. Buying heating and cooling equipment without a proper load calculation is exactly like walking into a shoe store, closing your eyes, and just grabbing a box off the shelf without checking the size. It has to be an exact fit to avoid constant misery. You wouldn't guess your shoe size, so why on earth would you guess the size of your home's most expensive and vital appliance?
So now that you know this scientific measurement is the real secret to indoor comfort, I've got a question for you. Was the system in your home or office ever actually calculated? Just look around your current room right now. Think about the temperature as you watch this explainer. Was your environment engineered with a precise heating and cooling load calculation, or did someone somewhere along the line just take a very expensive guess? It's a provocative thought for sure, and it might just explain why you're reaching for that extra blanket right now. Thank you so much for joining me to decode this topic and keep questioning the science around you.